Good afternoon, grade 8s, and welcome back to another bumper episode with Mascu Miller Learning and Mascu TV. Today's focus point is on the interpretation of graphs. No, not drawing graphs, interpretation. So when you see the word interpret, I think what should come to mind is basically expounding on, expanding on, and getting some insight as to what is happening. That is all we're going to do in this particular section. We're going to find out what is happening all around this topic of graphs. Now, obviously, before we start getting into it, there are certain objectives that needs to be attained at the end of the lesson. What are these objectives? We need to analyze and interpret graphs through linear and non-linear relationships. And before I continue, there will be a lot of new terminology that you will notice during the course of the lesson. A lot of new words, a lot of new vocab that need to be focused on, but it's okay. We're going to go through it step by step to make sure that at the end of this lesson, you are comfortable. All right? So we're going to analyze and interpret through linear and non-linear, through dependent and independent variables, through constant, increasing, or decreasing trends, and then lastly, interpret features of a graph such as maximum and minimum. All these terms which seem unknown to you now, we will bring to light during the course of the lesson. But before we can start with the topic of interpretation of graphs, we need to ask ourselves, what is a graph, right? And a graph shows the relationship between two quantities, which is what? The dependent and the independent variable, or the input and the output. But very important, what I want to emphasize here, it is quantities which is shown in a diagrammatic way. So obviously, if we look at the word diagrammatic, what comes to mind? A diagram, and a graph is a diagram. So we're not going to be dealing with numbers only. We're not going to be dealing with algebra only, and with calculations only. No, we're going to look at a diagram, and we're going to try and understand what is happening in this diagram given to us. That, boys and girls, is what interpretation of graphs is all about. So, the quantities being referred to here are sometimes called the input and the output values, and they're also referred to as variables, right? We call them the dependent and the independent variables, right? What are graphs? It is a visual way of indicating trends, right? And you can think of so many trends. You can think of trends in the space of, cars or cell phones or even shoes that people are wearing, right? And then a graph can be continuous. Notice here, what is continuous? It consists of a solid line, or discrete, consisting of a set of points. Don't worry, we will bring this to light in the slides to come. But this is just a basic overview of what graphs actually is. Now we're going to get into it, right? Now this terminology that we're about to go through is very important going forward in terms of interpreting graphs. And this doesn't stop here. This particular chapter goes up to grade 12. So it is very important that we understand the very, very basic fundamentals here, right? A linear relationship. Now I want to pause and I want to ask you a question. What do you notice? What is the root word of linear? It is line, okay? A line. That's what it's about. It's when the relationship between the dependent and the independent variable, which we will come to, by the way, is represented on a line graph, and the line is straight. Okay? It's a straight line. That is a linear relationship. So think about the root word of linear, which is line, and that line needs to be straight. That is when we're talking about a linear relationship. And then obviously, a non-linear relationship mustn't just be the opposite of that. It is when the relationship between the dependent and the independent variable is represented on a line graph, but the line is not straight. And here we have a perfect visual representation of what a linear relationship looks like and what a non-linear relationship looks like, okay? Let's move on. Very, very important. A dependent variable, and just have a look at the picture I've given you at the bottom. A dependent variable is affected by another variable, and it's the variable that you are observing. it is known as your output value. So the dependent variable is known as your output value. If you look at that on a graph, right, or on a set of axes, right, we have an x-axis, which is represented by a horizontal line, and we also have a y-axis, which is represented by a vertical line. So we associate our dependent variable to the y-axis, and we associate our independent variable to the x-axis. But what's very important here is to understand that this dependent variable is affected or manipulated by another variable, which is what? Which is your independent variable. And it says there for independent variable, this variable is not affected by another variable, right? And it is referred to as your input value or your x value. Very important. And this over here is the variable that is what? Not manipulated, right? So manipulated versus not manipulated. The one that is affected versus the one that is not affected. The independent variable we have control over. We choose what our independent variable is. However, we do not choose what our dependent variable is, because our dependent variable will be determined, or the outcome will be based on whatever the independent variable is. I hope that made sense. And you will see how it will come to light in the questions to come. Now, next point of importance, a maximum point and a minimum point. So the maximum value or the maximum point, before I get there, just think about what comes to your mind when you hear maximum. Do you think of highest, or the biggest, or the peak, or the top? That's exactly what it is. So the maximum value is a value that the dependent, we establish now that the dependent variable is this y-axis over here, can have in a graph. So if we look at this dependent variable over here, the y-axis, what is the maximum number it is reaching? So there's two numbers that is touching this graph, or which the graph is touching on this dependent variable. It is 9 and -9. That's very obvious. So now the maximum point is obviously the highest or the biggest number, right, that is touching this graph. And we can see here clearly it is the number 9. That is the maximum or the biggest value that a graph can reach. And then the minimum point is then just the opposite, the minimum value that a dependent variable can have in a graph. So if we look at the dependent variable, which is my y-axis over here, the smallest or the lowest number or the minimum value it is touching here is obviously -9. All right? Very important to understand. And then I think we're almost done with the information. Then we're going to go on to application. So what's a continuous graph? It's a graph made up of sets or points that are joined by curves, or it is joined by a line. And then a discrete graph is then a graph that is also made up of sets of points, but the only difference here is that it is not joined by a line and it is not joined by a curve, okay? Very important to understand the difference between the two, all right? Excuse me. So we have learned some very important concepts. We have learned about linear versus nonlinear. We've learned about discrete versus continuous. We've learned dependent, independent. We've learned maximum and minimum. It's a lot of new information to take in, but the good news is we can come back to this video. We can consult our spot on our Math Today, Classroom Mathematics Platinum. We can consult those textbooks, and we can also just ask Masky if we need help. All right, let's see what the example says. So it says here that the graph shows rainfall over the last 7 days in Cape Town. So here's the rainfall in millimeters, and then this is how much days it has happened over. So now they're asking us to identify the features, right? They want us to identify the features on the graph. So what I want you to notice here, firstly, is that we have a graph which is represented by a dependent and an independent variable, and they are asking us to interpret what's happening here. So we must firstly understand that we have rainfall that is given in millimeters, so it ranges from 0 to 16 millimeters, and we have time in terms of days, so we're working in days here, that is given by our independent variable over here. And this is what it's all about. It's about interpreting, understanding, expanding on what is happening in the picture over here. So, to answer the first question, let me just change my color because we can't have black on black. So, by A, it wants us to identify what the dependent variable is, right? And we said the dependent variable is the variable that we are observing, right? The one that is affected by the independent variable. I'm going to erase that. There we go. So, obviously, in this case, there's so many ways we can look at it. We can think of the one that is affected by the independent variable. We can think of the dependent variable that is the variable that we are observing. We can think of the dependent variable as the variable that is on our vertical or on our y-axis. There's so many ways to look at it, right? So obviously, my dependent variable is the rainfall in millimeters, right? So that is the rainfall in millimeters, that is what my dependent variable is. And then the independent variable, right, is obviously the one that sits here at the bottom, the one that is not manipulated or that doesn't change, right? So the independent variable is obviously the time, which is given in days. So to answer the question for B, it is the time, which is given in days. All right, and then the next one is asking, identify the maximum value, right? The maximum value. So it's the maximum value for our dependent variable over here. So I want to know what is the highest number or the maximum value that my dependent variable is reaching. So here's my dependent variable. And if I look, it's obviously here. So this blue dot over here is representing the highest value that my dependent variable must reach. So what do I need to do? I just need to check which number it aligns with. And obviously here it is what? 15 millimeters over there. So my answer is just 15 millimeters over here. It's very simple to just look and make an observation of what is the maximum value that this graph over here will reach. It is obviously that dot over there, but I must see which number it corresponds with. It corresponds with 15. And then the next question is obvious. It's asking us what is the minimum value that the dependent variable will reach. And I just look on this graph that I'm interpreting now. What is the lowest point given, right? It is this point over here, and that corresponds with 2. Okay, so 2 millimeters is what my minimum value will be. This was all under number 1. And then to answer number 2, before we go for a very, very short break, is the graph continuous or is the graph discrete? Now remember, we said continuous graph is a graph that has points but is joined by a line or it's joined by a curve. And then discrete are just points in a Cartesian plane or points that is not joined by a curve or a line. Obviously, these points are over here. It is not joined by a line or a curve. So that is why this graph is therefore discrete. So this is a discrete. Let me make that D a bit neater. So this here will be discrete. Okay, and there I've answered my first question on interpretation of graphs. It is very, very simple, but I want you to realize and understand that the information that was brought across in the beginning is so important for you to know before you can answer the questions that is being asked. So I'm going to cut for a very, very short break, and thereafter we will tackle the activity on interpretation of graphs. Stay tuned. Welcome back, grade 8s. I hope that you could just have a quick look at what the activity is on the interpretation of graphs, right? A section which is very easy to understand if you are familiar with very, very key concepts, right? So I want to get straight into an activity on graph interpretation. So let's see what the question asks us. It says there, we need to understand what is happening before we can answer the question. So they always give us some information about the graph, and that allows us to then answer the questions easily. So it tells us there that the graph shows distance in kilometers that a hiker walked for part of the day, right? So this time in hours represents some part of the day he was walking. We don't know what part of the day, but some part of the day. What we do know is the hours given to us, and it is also telling us how much distance in terms of kilometers that this particular hiker has walked for that part of the day. Let's see what the question asks us. Let's interpret what is happening over here. Let's look at question A. So now it's saying, so after how many hours did the hiker take a rest, right? Then we need to explain. So obviously, this is the distance that is being traveled, and this is the hours. This is the amount of hours that he has walked over here. So we can see that here he's walking for 5 kilometers. And then once he hit 10 kilometers here, how long is he walking for? He's walking for 1 hour. So here he's walking, and the distance is increasing, meaning he's walking and walking and walking. And then all of a sudden here, it comes to a halt. So it comes to a stop here. So obviously, if the distance isn't increasing, it means he isn't walking. Because if I am walking, I'm covering distance, right? In meters. And eventually it becomes what? Kilometers. So obviously, if this kilometers here isn't increasing, it means he took a rest. So I hope that made sense, how we are connecting the distance with the time he's walking. So after how many hours, so if walked, he walked, and then here it comes to a halt, it comes to a stop over here. So if we just look at where it comes to a stop, we need to look at the hours represented over here. And obviously the time here is what? 2 hours. So after 2 hours, he took a bit of a rest. So this man is very fit because he could walk for 2 hours straight before just taking somewhat of a rest. All right? I hope that made sense. Then it's asking, for how long did the hiker take a break? So we need to see, okay, so for how long wasn't there an increasing trend, right, in this distance that they has covered? So it's only once the distance is what? Increasing, it means he is walking more. So we can see here between these points over here, between these points, let me just do that. There we go. Can you see? There's no increase in terms of the distance, meaning he wasn't walking. And then obviously the difference between 3 and 2 is what? 1. So we rested for 1 hour, we took a break for 1 hour before he continued. All right? So here for B, how long did he take a break? He took a break for 1 hour. What you're doing now, boys and girls, we are interpreting what is happening here. Okay? Then for C, let's see what C is asking us. It is asking us, how many kilometers did the hiker walk before he took a second break? So they want to know, from the time this hiker started to walk, right, how many kilometers did he walk before he took a second break? So we started walking here. He started walking. There's the first break. How do we know? There's no increasing trend in terms of the distance covered. Then here we have another increasing trend over here, which means he has walked here, right? He has walked all those kilometers over here. And then here, again, what's happening here? Here it's coming to a halt, right? We have a constant over here, meaning that he hasn't walked over here. So they want to know, how many kilometers did he walk before he took a second break? Here's the first break. I'm going to circle it. Here's the first break. Here's the second break. We're interested in how many kilometers he has walked, which is what? The distance. So I look at my distance over here, and then I'm going to go here, and I can see here, at this point, this is when he took the second break, and that corresponds with 25. So he has walked 25 kilometers in total before he took the second break. Okay, they're not asking how much kilometers did he walk between the first and the second break. That would have just been 25 minus 15, right? He would have walked 10 kilometers before he took the second break. But they're asking, how long did he walk in total before the second break? It was 25 kilometers, all right? So my answer here is 25 kilometers. All right, moving on. How many kilometers did the hiker walk in total? So in total, it is just obviously everything all together, right? So it's walking, resting, walking. We're interested in the total amount he has walked all together, all right? So I'm just going to erase my screen so we can see the graph clearly. So here you covered 5 kilometers, 10, 15, and then 20, 25, all the way. And at this point over here, this is where he stopped, right? He didn't exceed this, right? So I'm going to go to my dependent variable, and I'm going to see how much distance he has covered in total. That was what? 40 kilometers, right? I just go across to my dependent variable to see how much distance has been covered. So here it is what? 40 kilometers. That's a lot of kilometers he have covered in that space of time. And then the next question is asking by E, what is the average speed over the whole distance? Now, you must have learned that how do we calculate speed? Speed is calculated by what? It is the distance divided by the time. Isn't it so? Yes. Is the distance given? Yes, it is. Is the time given? Yes, it is. So, they're asking us how much kilometers did the hiker walk in total. So we want the total kilometers by the total time he has covered to walk that kilometers. So the total kilometers the hiker has walked was 40 kilometers, right? So it is 40 kilometers over what is the time. But the time is given where? It is given in my independent variable. So at this point where the hiker has stopped, I go down to check how much hours the hiker has walked in terms of what it was given. So how much hours was that? It was 7 hours, all right? And then obviously, you can just do long division. 40 divided by 7 gives us approximately 5,86, right? Speed, right? So what is the speed? So we have walk at the speed of 5,86 kilometers, right, per hour. Per hour, right? Because our independent variable is given in hours, all right? And then, let's see what they're asking by F. Is the graph increasing or decreasing? Now be very careful here. Do this graph have a trend of increasing or does it have a trend of decreasing? Increasing going up, right? An upward trajectory, right? And decreasing is what? A downward trajectory. It is very obvious here that we have an increasing trajectory over here, all right? So here we can say increasing, right? And there's various reasons we can give there because the more time that is being walked, the more distance is being covered, all right? And then lastly, for G, is the graph continuous or discrete? And if we paid attention, in the earlier part of the lesson, we said a graph is continuous, right? If it is joined, if the points are joined by a line or a curve, and it is discrete if it is not joined by lines or curve. These points over here, remember, here with this 1 and this 10, this is a point that is forming over here. With this 2 and this 20, it's a point, right? But all these points, it is joined by a line or a curve, and that is why this graph is indeed what? Continuous, all right? This graph is continuous, all right? And that gave us an overall view of how we interpret. We have just interpreted this graph. We took 1, 2, 3, 4, 5, 6, 7 questions. There's so many more questions that they can ask us, but that, boys and girls, is the idea of interpreting graphs, all right? Very, very quickly, we're going to go through another graph, right? Given a different scenario. This scenario is showing the monthly car sales at a dealer over 8 months, right? So this is how much cars the dealer sold, and over this period of months it has been sold. So very, very quickly, we're just going to interpret this graph and see what the question is asking us, right? Firstly, again, we have the number of cars sold and the amount of months that is given. How many cars were sold in month 4? So I just go to my independent variable, which is represented by the months. I go to month number 4, right? And I just connect that and see, okay, so that is month 4. How many cars? And I just connect that with my with my dependent variable, and I can see there in month number 4, I sold 25 cars. So very straightforward, 25 cars were sold over there. It is just a relationship in the beginning between my dependent and my independent variable. That's all it really is, right? For B, it asks, what is the maximum number of cars sold in any month? So I go to my dependent variable and I just look at the maximum point that this dependent variable is reaching. Here's the maximum point, and I'm going to see what it corresponds with, right? It corresponds with this number here, which is 1 above 30, which is what? 31. So it is 31 cars, right? 31 cars. That's a lot of cars to sell, right, in 1 month. Let us see what C is asking us. In which month were the sales a minimum? And then it says, state the minimum value. So firstly, in which month was the sales minimum? So I'll look, what is the minimum point that this graph is reaching? The dependent variable. So the minimum is obviously here. And I see in which, the question is actually asking us, in which month, right? So here, my month is represented here by my independent variable, and it's very obvious here. It is month number 7. So my first part of my answer is month 7. The second part of my answer is asking, what is the minimum value? The minimum value is 1 above 5, which is what? 6, right? It is 1 above 5, sorry, it is 2 above 5, which is 7, right? So it is also 7 cars. So it is month 7, and it is 7 cars as well. Right. When is the graph decreasing? Very interesting question. So we notice that there's an increasing trend and a decreasing trend. So we can see here from month 1 to month number 3, there was an increase in the car sales. But then all of a sudden, from here onwards, it is what? It is taking a dip. So can you see here, from this point onwards, it is dipping down, right? It's no longer an increase. It increased all the way to there. Right, and then all of a sudden, it just took a downward trajectory. So between which months, right, or when is the graph decreasing? We can say between the 4th month and the 7th month. That is when the graph is decreasing, right? So I can say between month 4 and 7, that's when sales weren't as good, all right? And then it's asking, can we join the points, right? Can we join the points? Is it possible for us to join these points? So we can't join these points because this is an unpredictable graph. We don't know what's going to happen after the 9th month, right? And this obviously here is what? Discrete, right? So continuous is when it will be joined by a line or a curve, right? But these points, no, we cannot, because the information, we can say the information is what? It is unpredictable, right? We don't know what's going to come after the 9th month. All right? And then it is asking again, can you predict the number of cars that will be sold in the 10th week? So again, let's interpret this graph and see, can we predict what's going to happen? So from month 1 till month 3, I had an increase in my car sales. From month 4 to month 7, I had a decrease in my car sales. And then all of a sudden, I had another increase, right? So from this point, it is not consistent with an increase or a decrease, right? So in other words, I can't actually predict how much cars will be sold in the 10th week, because this graph had a trend where it was increasing and decreasing simultaneously. So in the end, I can conclude, can I predict the number of cars sold in week 10? No, I cannot, because the graph had a mixture or a combination of increase and decrease in car sales. Okay, boys and girls, I hope that lesson gave you insight as to how we interpret graphs. Very important for you to first familiarize yourself with the terminology of the topic, and then we are able to answer questions. If we don't know independent, if we don't know dependent, if we don't know discrete, if we don't know continuous, and then obviously it's going to be difficult for us to actually answer the question. So as you can see here, I left you with some homework. At this point, you can just press pause, you can come back, answer the questions, see what you are able to do, based on what we were given. So boys and girls, thank you for joining us today with graph interpretation. If you do need help, you can reach out to Masky TV on the number 072 091 0388. We are here to help you. We are here to assist you, right? Just message the number on WhatsApp. Don't forget to like and subscribe, and we will see you next week. Thank you. Bye-bye.
And now we enter our next exciting chapter with the launch of Maskyverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.